Hello and welcome to the sixth probability video, and we're going to look now at possibility spaces, and this involves drawing a table to help us work out probabilities of combinations of events, and that table is called a possibility space. It's not a particularly helpful title, but we'll just think of it as perhaps a table. So we've got an example here. We've got a spinner which has got numbers 1, 2, 3, 4. The sections are equal, so there's an equal probability for each number. The spinner is spun twice and numbers are multiplied to give a score. Complete the table and calculate the probability of getting an even number and of getting a number greater than 8. So here's a good example of where we would use a possibility space that would really help us. So we've got to fill in what the scores are on that table first of all. So if we get a 1 and a 1, that will give us a total of 1. Because remember, we're multiplying the numbers to get the total. So a 1 and a 2 gives us 2, 1 and a 3 gives us 3, 1 and a 4 gives us 4. 1 times 4 is 4. So if we get a 2 and a 1, then that's 2 times 1 is 2, and you can see the rest of the numbers appear in there. So that gives us a table of all the possible scores. So let's just clear everything out of the way. Now we can work out probability of anything happening. We notice that there are 16 possible outcomes. There's 16 numbers there in blue, showing the 16 possible outcomes. And the probability of an even number, well, we need to count up how many ways there are of getting an even number. So let's do that. Then we've got 1, there's a second even number, there's third, fourth, and you can see then, there we are, how many even numbers. I make that 12 out of 16. So that's the probability of getting an even number. Then we can cancel that down to 3/4, but as I've said many times before, we don't have to cancel them down. Let's have a look at getting the probability of a number greater than 8. How many ways are there of getting a number greater than 8? Oh, what have we got? 1, 2, 3, 4. Out of 16, so that's the probability of getting a number greater than 8. Remember, it's greater than 8, so that doesn't include 8, and we can cancel that to 1/4. So that's a good example there to see how useful a possibility space is. Let's have a look at an exam question, and in this one there's quite a bit of text, so that's potential difficulty there, but the question says there are 4 balls numbered 1, 3, 5, 7 in machine A and 4 balls numbered 2, 4, 6, 8 in machine B. Both machines select 1 ball at random, and the score is the product of the 2 numbers. Now, product means multiply, and it gives us an example. So we've got to complete the possibility space, and that's a very common question. So let's have a look at this one. We've got a 3 and a 6, so that gives us 18. Next one, we've got 5 and a 6, that gives us 5 sixes, it's 30. 7 sixes, 42. What about over here then? We've got 3 times 8, 24. 5 times 8, 40, 7 times 8, 56. And notice we get 2 marks for completing the possibility space. So now let's have a look at part B, and that's going to ask us the probability of something. And we can see this is quite an involved question, and we quite often get quite long questions once we've completed a possibility space. So let's take this bit by bit. So we've got a player wins a prize by getting a score of 12 or less. So we need to work out the probability of getting a score of 12 or less. So how many possible outcomes are there? Well, there are 16. Number of ways of winning, getting 12 or less, there's 1, 2, 3, 4, 5, 6, 7. So the probability of winning is 7 out of 16. Okay, now the next thing they tell us, there's ATP to play the game once, and 160 people play the game. So we need to work out how much money that's raised. So the money taken, 160 times ATP. Now that's a difficult calculation to do. Remember, this is a paper 1, so it's a non-calculator. But we could work out 16 eighths. Best way of doing that is say 10 eighths is 80, 6 eighths is 48. And if we add those up, we get 128. So 160 80s, we just put 2 zeros on the end. We got 12,800 pence, which in other words is £128. Okay, the prize for winning the game is £1.50, and we've got to find the profit. So we need to work out how many people we expect to win. So 160 people play, Now 7 out of 16 is the probability of winning, so that is 70 out of 160. 0 on the end of both numbers, so we would expect 70 people to win. Right, so we have to pay each one of those 70 people £1.50. So 70 times £1.50, well, 70 times a pound, £70. 70 times 50p, £35. Add them up, £105, and we can then work out our profit. 128 minus 105 is £23. So that question went on quite a bit, but it's a good example of a kind of exam question we would face after we've completed our possibility space. So, over to you now to have a go at the exercise, and it's bye from me, and I'll speak to you on the next one, which is the last one. Bye for now.